Here we have a city math problem. Okay, let's go to the question. A small business owner budgets $3,600 to purchase timber each year. The owner must purchase a minimum of 345 slats of timber each year to maintain the discounted pricing. If the owner pays $7.25 to purchase each slat of pine pulpwood and $24.75 to purchase each slat of pine saw timber, what is the maximum number of slats of pine saw timber the owner can purchase to stay within the budget and maintain the discounted pricing? Okay, let's assume X as the number of slats of pine pulpwood. Let me write the stuff over here. Number of slats of pine pulpwood. And Y as a number of slats of, let me write it, pine saw timber. Let me write the stuff over here. Okay, according to the information, the owner must purchase a minimum of 345 slats of timber each year to maintain the discount pricing. So the total number of slats has to be 345 or greater than 345. That is, we know that X represents the number of slats of pine pulpwood and Y represents the number of slats of pine saw timber. So when we add X and Y, we get the total number of slats. It has to be 345 or greater than 345. Let me write it. According to this information, I got this inequality. Now let's consider the information we have over here. That is the cost of each slat of pine pulpwood is $7.25. Then what is the cost of X number of slats of pine pulpwood? We have to multiply the cost of one slat of pine pulpwood, that is $7.25, and the number of slats of pine pulpwood, that is X. Then we get 7.25X. And the cost of each slat of pine saw timber is $24.75. And what is the cost of Y number of slats of pine saw timber? I have to multiply this 24.75 and this Y. Then I'm getting 24.75 Y. Okay, when we add them, we get the total cost of the purchase. And there is an information that the owner has a budget of $3,600. Then the total cost of the purchase cannot exceed this budget $3,600. So the value of this expression can be equal to 3,600 or it has to be less than 3,600. Okay, to get the maximum number of slats of pine saw timber the owner can purchase, we have to solve for the maximum value of Y in the system of two inequalities over here. Because Y gives a number of slats of pine saw timber. When I get the maximum value of Y, that gives a maximum number of slats of pine saw timber the owner can purchase. For that, we have to sketch the graph of this system. Okay, now let me use the Desmos to get the graph of the system of two inequalities. X positive Y greater than or equal to 345. And the second inequality is 7.25X positive 24.75. Y less than or equal to 3,600. Okay, here I got the graph for the system of inequalities over here. And this is a common region. Okay, even though it is a common region, we cannot consider the points we have over here because in all the points in this region, the Y coordinate will be negative. Y value cannot be negative because it represents the number of slats of pine saw timber. It cannot be negative. Okay, now let's consider only this portion of the common region which satisfies both the inequalities over here. And now let's consider the point of intersection of the two lines we have over here. The point of intersection, the Y coordinate is 62.78571. When I enter into the common region, the Y value is getting decreased and the X value is getting increased. Since Y value is getting decreased when I enter into the common region, so this is the maximum value of Y. So we can write this one as an inequality. That is, Y can be equal to this value or it has to be less than this value. So that is Y is less than or equal to 62.78571. And we know that the number of slats of pine saw timber cannot be decimal, always it has to be an integer. So Y always must be an integer. So we have to consider the first integer which is less than this value, that is 62. So we can rewrite this inequality as Y less than or equal to 62. So therefore the maximum value of Y is 62. So that is the maximum number of slats of pine saw timber the owner can purchase is 62.